So yeah, hi everyone, and welcome again to our second session of this series, where we are talking about data center and hybrid cloud. So as we mentioned, our main aim of this session is to take you from the foundation to master the cloud technologies. Today, I have again my colleague, friend, and technology expert, Zig Ziga. Happy to have you again, Zig.
Yeah, thanks, Mohammed. I'm really excited again. As always, this is fun stuff for us. We really do enjoy it a lot. So,
Good. Are you ready to talk about the data center interconnect, starting from the old DWDM till the latest?
yeah, I think it's going to be really informative. So I would ask the group that's on here today. I'm a very interactive kind of talker, so there's going to be some questions that we're going to ask. I want you guys to be very involved, right? That's the whole point here. So we're going to go through a lot of content, a lot of questions in the Q&A and whatnot, and I want you guys to ask your questions, get something out of this kind of webinar. And of course, after the session, if you have follow-on questions, just reach out to us. We will support you in any way we can.
Great. So yeah, let's move to, so as I mentioned, today the second session is dedicated for Data Center Interconnect. We are trying to talk about the options, evaluate them, and we promise you by the end, we will give you a very nice chart about these technologies and some criterias. We spent a couple of days between myself and Zig building this chart, so hopefully you will like it. So yeah, if we go to the next slide, so as you know, Zig is almost 20 years experience in the field, working with Cisco as a customer delivery architect. He's a mentor, author, and he has his own consultancy initiatives. And myself as well, you know, I'm working as a principal solutions architect based in Australia. Zig is living on the other side of the world in New York.
Almost yeah, pretty much the exact opposite hemisphere, right? Of the world.
Yeah. So if we just kick in Zig, and as we mentioned, to keep it interactive, let's ask our audience first. Why do you think, from business perspective, not from technical, from business perspective, why do you think we need to have this data center interconnect? If you want to unmute yourself and talk, or if you want to put it on the chat, feel free.
Yeah, so this question's kind of important, right? Like when we're talking about design and any aspect of design, we need to understand why we're doing it. And so this is kind of a leading question. Why do we need a data center interconnect? And if we can't really ask and answer that question, then we're kind of at a loss, right? We're doing it for maybe not the right reasons. So as Mohammed asked here, he asked this question. So I'd like to hear from you guys, in your perspective, why do you need a data center interconnect? You can feel free to unmute yourselves, answer the question. Again, we're going to try to make this interactive as possible. No one wants to take a guess? So let's think this through, right? So a data center interconnect, what is a data center interconnect? Can anyone kind of help me with that? Anyone want to chime in? I know it might be late or early, so.
Yeah.
Yeah, this is Aliu. As the name is saying, is to interconnect data centers. Like we have two data centers in two countries or in two continents, and we have an interconnection between these two data centers.
Nice. Okay, that's great. So that's perfect, right? And then also I got, I think Sarah in chat said high data rates, better performance. So those are great feedback, right? So there's a lot of reasons why we would have a data center interconnect. And I think to summarize them, they really go back to the business and what the business is trying to achieve. And we're going to cover down in a number of those things that we're going to talk about. Why is a data center interconnect needed, and what the business is going to get out of it. Of course, there's going to be technical reasons that you're going to get out of the data center interconnect, but really, what is the business trying to achieve? So as we talk about what the business is trying to achieve, the next question I have is really, what are the problems, right? So as we talk about these different solutions today, I want you to take these two questions and keep asking yourself these questions, throughout this session, because why are you doing it? Extremely important. And then, what is the problem you're trying to solve from a business standpoint? Most businesses are trying to make money. Most businesses are trying to reduce cost, unless you're not for profit, which is a little different. But if you're trying to make more money and you're trying to reduce cost, some of those business problems, how are you going to help with the data center interconnect? And then my last bullet on this slide, and you're gonna get, this is who I am, right? And I harp this constantly. We as designers, as this group, we should be constantly asking why, every step of the way. I want you to picture like a 4-year-old or a 5-year-old child, right? And all they do is ask why, constantly. Why is the sky blue? Why is the grass green? Right? That should be us, obviously not for those basic questions, but more like, why do you need a data center interconnect company? Why do you need to span VLANs? Why do you need layer 2 mobility across data centers? Those are the questions that you should be asking the company, the applications team, the developers, their team, and then obviously the IT team. Why are we doing this? Are there any questions so far? Those are kind of just some quick questions that kind of set the stage today.
100%, Zach, I agree with you. As a designer and architect, you need to start asking why. Maybe when you're working on operations and implementation, you ask more like what and how. This is also what I teach a lot in my CCTE trainings. So why is the key? You need to understand the reason behind it. And before trying to solve a technical problem, you need to understand how this will either get a benefit to your business or solve a problem. So usually you are trying to get one of the two. If you get both of them, then you are genius, it's better. So if we jump to one of the main business requirement from the Data Center Interconnect, we can say, as here in the slide, I believe business continuity is a key, which some of these fall under. You don't want to put all your workload in one data center, and if this data center crash or anything happen to it, you lose all your IT resources, which becoming now, as we mentioned, IT is the key for all the business, not only for network and telecommunication industry. So yeah, go ahead. What else you have for us for these use cases?
Yeah, so for this slide, right, Mohammed and the team that's on the call, right? So this is not an all-inclusive list, right? This is not like this. There's not only 8 business use cases. There's a whole bunch of business use cases. These are the top, I would say, most common business use cases, and I'm just going to briefly cover a couple of them. And of course, if you have questions, you can send them in chat. You can ask them on the call. Feel free to, right? Again, I want this to be interactive. So obviously, Mohammed touched on business continuity, right? Again, you don't want everything in one. What's the saying? You don't want all your eggs in one basket, right? You don't want to put everything in one data center and be like, yeah, all my stuff's in a data center, and then that data center goes down, and now you lose everything. And that's probably the simplest business use case that 90% of the customers use today, right? They want fault tolerance, they want high availability, they want active standby, a hot site, and then maybe a cold site or a warm site in some fashion. And those words I just said are actually a lot of work, right? So those are easy words to say here, but the background of that is there's a lot of work that has to go into it, a lot of design and implementation technologies that have to go into making those warm and cold sites or hot and cold sites actually functioning. The workload mobility has become probably the next common one these days, right? The ability to move workloads from data center to data center. And the key aspect there is it layer 2 mobility or is it layer 3 mobility? Layer 3 mobility we can do is pretty inherent, right? Across the board, it's really just you're changing IP addresses. And I'll give you a quick example of that. You can easily do some scripting with some of the fault tolerant solutions out there. I'm always trying to be vendor agnostic here, so I'm not going to call out the solutions, but you can do some scripting where you can on the fly update DNS as you move a workload from one data center to another data center, and you would change its IP, update DNS, and now that application lives in that other data center. That'd be like a layer 3 mobility kind of design. More probably pronounced or more really out there today is a layer 2 mobility, where they don't want to change IP addresses, right? They don't want to change subnets. No one wants to go through that hassle. So that there's solutions that we're going to talk about today that really cover that, right? You're going to have layer 2 mobility from one data center to another data center, and potentially even to 3 or more data centers. And we'll go over some of those solutions in a little bit. And then the other ones here, I mean, we can talk about them, right? There's a whole bunch of them here. Application geolocation clusters on the bottom right here. That's really just geographically separate data centers. So most likely you're not going to be having like a direct connect between the data centers. You're going to rely on WAN or the internet to get between them, and you're going to require a geolocation of some sort. There's load balancers that can do it out there today, and vendors that actually support that, where you can call the geocode and know, hey, if you're in this specific part of the world, you go to this data center. And if you're in, let's say, the US where I'm at, you go to the US or North America data center. But if you're in Australia, where Mohammed is, you go to the Asia Pac data center, right? It's really based on your location. It actually does a lookup on your subnet, your IP address, from where you're coming from. But we can talk about these if you have questions. Again, like I said, feel free to ask the questions in chat or live. This is just a quick, here's your business use cases, right? So moving on to the next slide here, we're going to talk about DCI options, right? And this is really the meat of what we're going to talk about today, is all the different DCI options. And the same thing, this is not an all-inclusive list. You know, we went with a dark theme here, but we got 12-ish options that we're going to highlight today. There's more than 12. And you might have more that you could talk about. If you have questions on some that we're not covering, let us know. But we're going to go through these. We have some diagrams. We'll call out these, and we'll just kind of talk to them a little bit. What I would ask is if anyone has some of these, as we get to it, let us know. So that if you have dark fiber today, if you have DWDM today, if you have LISP or OTV or VXLAN, just, you know, when we get to that slide, let us know.
Perfect.
All right.
Yeah. If I want to comment, Zig, on the, we don't need to get back to the previous slide, but from business requirement, take into consideration as a designer that based on this requirement, maybe it will affect your design. So if you are building, as we mentioned, just as a DR, as a disaster recovery, maybe the technology will use the replication mode, the type of the second data center, is it hot, cold, warm, whatever. So based on the requirement, this may affect your design of the data center itself and affect the best DCI option to use. We will not touch this today, but just a thought came to my mind, and I thought to share it with you, that for each business requirement or each business objective, maybe it will, for sure, it will affect your way to build the multiple data center and how to interconnect them. Another point that keep in mind, we are not only talking about your private data center or private cloud. We may consider any of the public cloud provider as your virtual data center. So maybe in the next sessions, we will talk which of these options we can use as example to interconnect with AWS, Azure, or Google, whatever. Yeah, back to you, Zig.
Yeah, thanks, Mohammed. Yeah, so to that point, right, like this is all building blocks, right? So our first session, we talked about a specific subset. We actually talked about internet edge architectures for the data centers and multi-data centers and how to get through to the internet and back and forth. And now we're talking about DCI options. These are all building blocks so that when we get to the next session and the subsequent session that we have, when we talk about cloud connectivity and we talk about getting the applications to the cloud, we can highlight, well, you know, everything builds together, right? This is a full end-to-end architecture from a cloud standpoint, but we have to start from the basics, and the basics last time was internet edge architectures, and obviously today is DCI options. And we can highlight them as we go through what might make sense for a cloud connectivity model. Any questions so far for the guys on the call? All right. If there are any questions, like I said, feel free to put them in chat, unmute yourself, ask the question again. I like to have an interactive kind of session. So our first solution that we highlighted is dark fiber, right? And this is, I would say, pretty simplistic. You have to either get your own dark fiber or get a provider that gives you dark fiber. You're going to have your two data centers, data center 1 and data center 2. And you might have 1 or 2 links, right? Just everything that we're going to call out today is going to have redundancy in it. So you're going to see 2 links. These links might actually be in an MLAG, like a port channel of some sort of group, depending on what you're running across this link, right? I would say dark fiber is one of the physical options. So as we go through here, you're going to have physical, you're going to have kind of service provider offerings or services, and then we're going to have overlay technologies, right? So we kind of broke them up into multiple buckets, if you will. Mohammed, did you want to say anything on dark fiber?
No, I believe we all use dark fiber, I mean, most of us, and it's one of the simplest physical, people call it layers 0, layer 1. It comes with its limitation, so maybe you can, if your data center around 80 kilometers, maximum 100 kilometers apart, you can use dark fiber, but if you have one data center in Paris and another one in Czech Republic, as example, you cannot use dark fiber for sure. If you have any comments, if anybody use dark fiber and can comment or has a question, this one is simple, so we can move on to the more advanced one.
Yeah, so I'll just say a couple things, right? Dark fiber is one of those things that you can run anything over it, really. Like you would have to manage it, right? So you could run layer 2 over it, layer 3, an overlay, and we'll get into the overlays. I mean, it could be really any of the overlays, right? It's going to be a fiber line that's given to you and handed off to you, and you plug it into your device, and now it's your device, your connectivity model. So you can do anything you want on it. All right, so our next one is CWDM or DWDM. I would say it depends who's running this, right? So if you're owning the ONS gear, the optical networking gear, and you're managing it, this can be complex to set up, to manage, to do new wavelengths and new lines. The big benefit you get with DWDM is you can have a small number of fiber links between your locations, and across those fiber links, you can run multiple fiber light paths, if you will. So let's say you have a 10 gig link. You could actually run, depending on your hardware, 4 10 gig links across that one 10 gig link. And that's just because it's using different light reflectors across that fiber, and it's actually isolating those paths. It's like a mathematical formula across that fiber pair. And that's really me being very vague and very high level, right? There's a lot more that goes into WDM. The benefits from a business standpoint is that if you actually set it up and you're managing your own ONS gear, you could theoretically have maybe 4 links between your sites, and those 4 links could actually be 20 links or 30 links, depending on the hardware you're running, right? And then depending on the infrastructure, you go 10 gig, 100 gig. I've seen customers go up to 100 gig, if not more than that, across DWDM. It is complex. The ONS gear is very complex. It is like a niche technology. Usually, I've seen customers outsource deploying it, managing it, and building it up, whatnot. So.
Yeah, 100% Zig, yeah. So if you compare it to the dark fiber, instead maybe of having multiple dark fiber, because each one you will terminate it on a device and either run it as a 1 gig, 10 gig, 100 gig, or whatever. But if you want to introduce a new link, you need to lay a new dark fiber. But for DWDM, as Zig mentioned, you have the possibility of multiplexing or ROADM. So here in the data center, later on, we can add another device connected to the OTN or ONS in Cisco world, and then get a new lambda connected to another side. If we want to add a third side, it can be part of this DWDM ring. So it's from solution perspective, it's flexible, scalable, but as Zig mentioned, it's somehow complex to design, plan, operate, and also, as Aloy mentioned on the chat, it's quite expensive. So one of the options to give you a lot of freedom to choose what to use with your bandwidths and connectivity, but it's come with its own challenges. And as you can see here in the dark fiber, we try to put the link as black, but in DWDM, we try to make it multiple colors, but to show you that it can carry multiple bandwidths or wavelengths.
Yeah. Thanks for the question, I think, Alu. Anyone else have any questions on WDM? WDM? No? If you do, obviously, just let us know. Our next one is L2 trunks with spanning tree, which is definitely not one of my preferred options. I'll tell you that right now. I am a big proponent against doing any type of spanning tree across data centers. You know, if you don't need to do it, why do it? Again, it comes back to why. Why are you doing it? Is there a business use case, right? Just because I hate spanning tree and I hate blocking links and whatnot, doesn't mean we don't do it. It's what's the business trying to solve, and then we have to make the design decision for that. So this is really basic, but hopefully it makes sense. I'll try to cover it. You're going to have switches in your data center. You're going to have a link between the data center. Maybe it's one of those dark fiber links. Maybe it's a DWDM link. Maybe it's some sort of Metro Ethernet link. And you're going to be spanning VLANs, right? So you're going to have maybe 10 VLANs, 100 VLANs going across that trunk, if you will. And then if you're not doing a port channel or an MLAG, whatever you want to call it, across these two links, then one of these links is most likely going to be blocking traffic, right? The whole point of spanning tree is to make sure there's no loops. So we're going to block one of these links, and maybe we'll do it per VLAN blocking. Maybe we'll, you know, offload that way. But that's really the architecture here at a high level.
Yeah, maybe if I may comment that I can share with you some of the real life scenarios that somehow maybe if you have one data center service provider or cloud service provider was available in data center one, and maybe the number of racks or capacity reach 100%, and they want to expand, so got a nearby location, and at that time it was old, early 90s and 2000, so they decided to get another location around 500 meters away, and they just connected in this way because for them they really care about layer 2 extension, and they didn't have the new overlaid solution which we'll talk about. So maybe you'll find this design a bit ridiculous or outdated, but as Zig said, you may face it in real life in some situation, as mostly like for layer 2 extension, for data center expansion within a small geographical location.
Yeah, and thanks, Mohammed. So you know, just because, and I'm being very opinionated, right? I don't like spanning tree across two data centers if I don't have to. There's a right way to do it, right? So it's not just because I say it's not the best idea to do it, doesn't mean you can't do it. And if you're going to do it, there's the right way of doing it, right? So if you're going to span links like this and you're going to do STP, knowing where your root bridges are for your VLANs, right? And identifying who your root bridge and your backup root bridge are. You should have probably 2 identified at a minimum. And then also running FHRP, so first hop redundancy protocol, or some fashion of that, right? Depending on what vendor hardware you're going with. Again, being vendor agnostic. You need to map up your root bridges and your FHRP configuration together. So if that, you know, if switch 1 in data center 1 is your root bridge, right? Then that's also probably where you want to do your FHRP, just so you guys have an idea, your default gateways, if you will. You wouldn't want your default gateways going to data center 2 if your root bridge was in data center 1, stuff like that.
100%.
High level, right? All right, so the next one, we're going to increase complexity, right? This is just L3 point-to-point links, right? So just routed links. We're not spanning layer 2 here. So this is, if you get dark fiber, Metro Ethernet, whatever, you're just doing some sort of routing adjacency across these links. Preferably here, I would make them equal cost multipath links, right? As long as they were equal bandwidth links, I'm assuming that here, right? Maybe they're 100 meg links or a gig link, both of them. Then make them equal links from a routing perspective, and that way you're routing traffic and go across both these links, however it sees fit.
Yeah. Again, maybe.
Good, Mohammed?
Yeah, I agree with you, Zig. So maybe you will face this maybe in a country where they still have ATM or frame relay. So you get so that's why service provider here is optional. You can build your layer 3 point-to-point links, maybe use an old technology like leased line or whatever, frame relay, or get it from a service provider, and then you start using a layer 3, not like the previous one, which was purely layer 2. Here it will be layer 3, and Zig mentioned we need to take care of all the best and optimal design practice for the solution to assure the controlling the traffic flow, controlling the for sure if you have multiple links, you need to use both of them with equal cost multipass and so on.
Yep.
So,
is anyone doing these today? Has anyone got L3 point-to-point links today? Just curious. I gave you guys.
Yeah, actually, I'm working on several projects. The previous option is spanning tree, multiple data center, around 3 data center, 4 data center, and other data center where we have A3. But the customer now is having a new project to migrate within a new site where we have VXLAN EVPN.
Yeah, that's awesome. Thanks for the feedback. Appreciate it. That's good to hear. I'd like to get an idea of what people are doing today, you know, see how if this is resonating or not. So for time, it's moving on here. 5 is MPLS L3 VPN. So here's one of our first kind of what I would call overlay technologies, right? So we're going to leverage some sort of provider network. Sorry, not overlay technologies. I misspoke. Service provider technologies. So we're going to leverage our service provider here, and we're going to, you know, we're going to get a contract, get an L3 VPN circuit at our sites, and we're going to run some sort of connectivity to that L3 VPN configuration in that cloud. Right now, this is a really generic, simplified version of the diagram. Right, a lot of cases you can you don't have to have a ton of links to the MPLS service provider in the same location. Right, the data centers traditionally will have 2 to the same service provider. At least in my experience, they'd have redundant links to your service provider. But then some of your branch offices may not have redundant links to the same service provider. And you're just hosting the services, right? So they're going to run an L3 VPN. They're going to run some sort of routing protocol, and you're going to do some sort of connectivity to that routing protocol. You know, you could even do static if you really wanted to. I'm not a big fan of static routes or tragic routes, just so we're clear. Like, they never go away. That's why they're tragic. So I prefer running some sort of IGP or even BGP here on your end so that you can inject and also receive routes from the provider. There's also load balancing mechanisms that you could do. A lot of the load balancing mechanisms here would be dependent on the provider themselves and what they're doing for you, right? So that'd be kind of out of the scope of what you would need to do. From a design perspective, if you were like the service provider engineer, then you'd have to come up with a solution to be able to load balance the networks at data center 1 across those 2 links, and then obviously data center 2 across those 2 links. And there's ways to do that. If you have a question on that, let me know. I can go into detail on that afterwards.
Maybe a question to our audience first, Zig, and then you can answer. Try to make it interactive. If we are comparing this option 5 with option 2, which is DWDM, so why would you go, instead of building your interconnectivity using DWDM as example or whatever, let's say it's a scattered data center in 2 different countries, why would you prefer to go to MPLS service provider to give you this connectivity? So this is one first part of the question, and what you will lose when you're getting this type of interconnectivity. Just comparing it to DWDM. Just quick 2 points if anybody can help us, and if not, we get back to Zig.
If not, you're going to put me on the spot, right? I got you. No worries. And just so you guys know, while we're waiting for someone else to answer that question, like, we didn't prep any of these questions, right? These are live, raw, real questions. So it's not like I have an answer prepped for Mohammed here. He's asking this question on the fly.
Yeah.
And thanks, Mohammed, for doing that, by the way.
Sorry for that.
Anyone else want to try for that answer to that question?
Yes,
I like these questions.
Regarding the DWDM, why move from the, let's say, like, for having the DWDM, when you have 2 DCs that are in 2 different continents, then you have this, how to say it, you have this constraint of this distance. So using a service provider, you can have a service provider that can span multiple countries and to connect your multiple data centers. And what are you going to lose when adopting a service provider, MPLS, is the control that you had in your network, that you don't have that control anymore. The service provider is going to control depending on the relations that you have and the contracts that you have with the service provider. And what you are going to gain here is the simplicity. You are not going to have to manage this DCI anymore. I mean, the DWDM, the service provider is going to manage it for you.
That was a great answer, man. That was great. Good job. Yeah. I don't know if I can do anything better than that. Anyone else want to add anything else? Yeah, so I'll just add a couple things, right? So DWDM is really location specific. So think of if you had two data centers in the same geographical area. What I mean is like, I'll use an example of a customer of mine without telling the customer information, right? So let's say you're a higher ed school, like a college, and you have a campus, and maybe you have two data centers, right, in that campus space. It's a pretty large campus. You have maybe a west campus and an east campus, so you have data centers in each of those. But you own the entire campus, right? You could really run your own fiber in that situation. So because you're running your own fiber, you could run DWDM. Again, you really want that fiber to be end-to-end that's going into DWDM. Right? You don't want that fiber leveraging another provider in any form. You want that almost like dark fiber. You want that to be like a dark fiber connection to your DWDM circuits or your ONS gear, which is costly and timely and really problematic because it doesn't scale to bigger geographical locations. Now think of if you were outside of the U.S. and you had a data center in the U.S., you had a data center in Sydney, like I have a data center here in my house in New York, and let's say Mohammed has a data center in Sydney in his house, right? It'd be very, very hard, almost impossible for us to run a DWDM circuit between our locations. It's just they're so geographically dispersed to get an end-to-end fiber line. Now you can do some virtualizations, technologies like pseudo wires and whatnot on the provider side, but it wouldn't be guaranteed end-to-end fiber, right? And that's really what you want with your DWDM at a high level. So there's that, right? There's some drawbacks with DWDM. MPLS gives you better flexibility from a location perspective in terms of a geographically separate location, right? So here we could do MPLS, and we could do an MPLS circuit here in my house to connect to my data center. We could do an MPLS circuit to connect to Mohammed's data center, and we'd be right up and running, right? It would be good to go. To a loose point, we would lose some control going to MPLS, right? We're not running routing by ourselves. The MPLS provider is doing some routing. They're taking our traffic and they're routing for our traffic, right? So we lose control potentially of quality of service, a response time potentially if we don't have that written in the contract. There's a whole bunch of things that can happen here on that aspect. Another thing to keep in mind is that I don't know if you're going to find a lot of carriers, a lot of providers that have one single MPLS cloud between different, like US to Sydney. That's a pretty geographically separate location from an MPLS provider perspective. So in most cases, you're going to have some pretty substantially complex service provider technologies. That's where we're going to get into like inter-AS options or carrier supporting carrier options, where you have, a child provider that is pairing up with a parent provider, and then they're doing their own kind of nested configuration. So you really do potentially lose a lot of control in those situations.
Yeah.
That was a long-winded and I'm rambling, so I will let you guys ask questions. Does anyone have questions on that? That was a lot, right?
Yeah. So yeah.
Mohammed, did I miss anything?
No. It's perfect. Nothing. As you mentioned, DWM is pricey. There are some physical aspects which can affect your solution. MPLS will make it easy. You are just like transferring some of the management of the core connectivity to a specialized service provider, but you are losing also control because you are sharing your routing information with service provider. That's why maybe some people will do a trick that, as example, maybe just share with service provider like a tunnel that's trying to create a tunnel and then build our routing protocol over this tunnel, which is a bit complex as well and come with its limitation. But as you usually, when you go to layer 3 VPN, you're losing a bit of control and you're sharing your routing with the service provider. That's why maybe the second option, which will lead us to option number 6, and they can say layer 2 VPN. I can start also with a question. Why people usually say that layer 2 VPN gives you more control compared to layer 3 VPN?
Are you asking yourself that question, or are you asking the audience that question?
Yeah. What, anybody want to answer, or I just mentioned
Yeah, I'm on it.
hint.
One second, Mohammed. I'll be right back.
Sure, take your time.
There's 2 milks in there. Yes.
So yeah,
Mohammed, I believe this is about the routing control between the layer 3 VPNs and layer 2 VPNs. In layer 2 VPNs, I think this is part of the customer network routing. The provider doesn't have control over this, unlike the layer 3 MPLS VPNs.
yeah, 100% Osama, yes. So as we mentioned, in layer 3 VPN, usually you have what we call PECE protocol. Either if it's a static or whatever protocol, you are still sharing your subnets and IP addresses with the service provider, and he take care of advertising this subnet from one location to another. But layer 2 VPN is just, you are building, as we usually say, like virtual leased line. So you just connect to this data center, maybe here in, I'll say this data center in Sydney, and the one in yellow in New York. So I just connect to this router in Sydney, and they connect to the router in New York, and the service provider will build us like a Z-wire tunnel, and then we can even use the same VLAN, the same layer 2. We can run our EIGRP or whatever. So the MPLS provider is not really participating in the routing protocol. So we have full control of our routing. Yeah. If you want to add something, Zig, about layer 2 VPN.
Yeah, sorry about that, guys. You know, this whole working from home and whatnot, and whatnot, you know, it's just a different world these days. So I apologize for that, but it is what it is. So for L2 VPN here, yeah, so again, this is a situation where you could have more control from a routing standpoint, right? So like Mohammed was talking about, to you, like you're going to get a layer 2 handoff really, right? It's going to look like it's directly connected to your other device in your other data center. So you can automatically pair up with that other device. You can continue spanning VLANs if you wanted. You can do a routing adjacency like we talked about, right? In the service provider network, they're doing what's called a pseudo wire of some sort, or an L2 VPN of some sort, right? And you're still dependent on the provider to do things right? So you still lose control in that aspect. You can't guarantee, unless it's written in the contract, that your service is going to be online all the time. But from a routing perspective, you maintain routing control because you're the one that's routing traffic for your networks, right? You're really doing what I would call almost like an overlay on top of the MPLS network, right? Because you're running your IGP or BGP as an overlay on top of the MPLS service, the L2 VPN. These are point-to-point, though, so there are some limitations there, right? So these are not point-to-multipoint or like similar to the next topic, which is VPLS. This is really point-to-point. So every site that you want to have this done, you have to have a dedicated point-to-point L2 VPN circuit configured. So that's just a limitation. All right. Any other questions on that? Again, I apologize about the interruption. All right, I'm going to move on to the next one. That's cool with everyone, which is VPLS. So I already kind of talked about it a minute ago. Our diagram here really just uses the same kind of topology, but instead of that point-to-point connection, we now have this virtualized local area network, right? We're really just creating almost like a switch, if you will, in the cloud, and everything that connects to that switch is actually on the same network, right? So it's not multiple broadcast domains, right? It's actually everything's on the same network. So you know, data center 1's connection to that one, you might have 2 connections here to from data center 1 into this LAN environment. Well, they're actually on the same network. They're on the same subnet theoretically. Same thing over here, right? They're going to be on the same subnet, same network. It's one like broadcast domain for all of this. Now, from a design perspective, as you get really more, I would say, complex, but that's really based on the need. There's advanced VPLS, or hierarchical, I can't pronounce the word, hierarchical, yeah, I can't pronounce it. Maybe Mohammed can help me with that word. I'm bad at it. But there's other advanced technologies for VPLS that make it more scalable, more efficient. So if you're a low scale implementation, then VPLS by itself would actually work. There's just some scalability numbers for MAC address learning with VPLS.
Agreed. If I may comment, coming from long years working for service providers, I can tell you that service providers hate VPLS, and they will try not to sell you VPLS. If you told them I need layer 3 VPN, they will be happy to sell you maybe 1,000 or 10,000 of circuits all over the world. Layer 2 VPN, they are happy to sell it. VPLS usually it's because it's painful for the service provider. As Zig mentioned, this is like a big switch, and all the PEs participating on this customer VFI or whatever the name per the vendor is actually sharing all the MAC addresses together. And all these PEs in gray need to be aware of all the MAC addresses. If there is a broadcast, it needs to, or unknown address bomb, as we mentioned, they need to share it with all the PEs participating in this domain. So that's why VPLS is not scalable. Service provider hate it, and even if they're trying to sell it to you, they will put some limitation like number of site and number of MAC addresses you can advertise over your domain. So it's still a good option for a customer, but I believe for a service provider, it's not preferable.
Yeah, the service provider is going to kind of box you in, right? They're gonna box you in because they're more concerned about it breaking their network. So they're gonna try to limit what you're allowed to do with this, because once they allow you to have it, you could really destroy their tables, because all those MAC addresses are going to be learned and flooded. And I mean, it's going to flood everything as part of this VPLS configuration. So theoretically, if this is a worldwide provider, right, your MAC addresses are going to get flooded every PE they have. That's part of this VPLS. That's high level stuff, right? So, all right, next one, if that's cool with everyone, is GRE and IPSec Tunnels. So we did have to add this one just so we could talk about it real quick. I definitely would say not a preferred option, right? A couple reasons behind that. These are going to, you have options to do point-to-point, multi-point, point-to-point and point-to-multi-point. So there's options there, so they're not set up to just do point-to-point circuits or IPSec tunnels. I think there's some inherent issues with GRE and IPSec tunnels across the internet. You lose the control over your applications, quality of service, for example, right? As it goes across the internet, you lose quality of service. So if you're trying to maintain any type of application performance standards, you won't potentially be able to maintain them in a guaranteed perspective across the internet with GRE or IPSec tunnels. Any thoughts, Mohammed?
Yeah, I was just going to comment that even I believe in the huge or large DMVPN or IPSec implementation, as example, if you are a bank having 2 data centers and having a lot of branches, a lot of ATM or point of sales, you may implement DMVPN. But I believe, I never see it in my life, that the 2 headquarters or the 2 data center, even they have a DMVPN solution for the spokes, they still use a different technology to connect the 2 data center, because still not reliable. IPSec and GRE, maybe this will change over the future. Internet will become more Internet 2 or so on. But so far, I believe this one of the options which is less preferred, unless you are really keen about budget. Your company said we don't have any budget for you to the DCI Interconnect. Go and connect them with $100 per month. So this is the only option you have.
Well, so actually, I actually highlight this option in my Cisco Live presentation every year, because if you don't have a budget, that's really where this falls, right? Because you can configure GRE and IPSec tunnels on pretty much most devices. There's probably some that don't, right? But most of the devices out there today have a way to do a VPN of some sort of tunnel, if you will. So, like, if you can't get a dark fiber link, if you can't get WDDM, if you can't get an MPLS circuit of some sort, L3 VPN, L2 VPN, VPLS, right, then this is the next option, right? This is like the bottom way to connect your sites together if you need to. But it is an option that does work. It just is not as preferred as the other options.
Yeah. Maybe a hint before moving, because I believe this one we are concluding somehow the legacy or the options, and we are moving to the new trendy or maybe more exciting. So just please, if you have any questions, don't be shy. We are all learning, and we are not mastering all these technologies. So before moving to the more advanced options, do you have any question or comment about this physical logical connectivity plus the service provider option which we mentioned? Maybe not. So we have a
All right.
brilliant.
So we're going to move on. I'm going to say that we're probably going to go over the time block, just so you guys are aware. We're probably going to go over the 9 o'clock Eastern. It was only supposed to schedule for an hour, you guys. So we're going to have more time. Like, I'm not going away. So we're going to cover all the concepts, all the slides here, and we're going to cover all the questions you have. I have my time blocked out for this. Obviously, I understand that some of you have to jump off. If you do need to ask any questions, my contact information is going to be available for you, and so is Mohammed's. We're on LinkedIn and Twitter and whatnot. And then we'll also send out the replay, right, the recording of all this once we're all done with it. So just keep that in mind. If you have to jump off, I understand, but we're going to keep going, right? We got a lot of content still to go through. So like Mohammed said, this is really the legacy overlay option. So GRE IPSec Tunnels was really kind of one of the first overlays that you could do that you control. And you're going to do that over whatever underlay you have, right? That underlay being internet, a service provider, you know, pick your poison, right? So this is the legacy one. Now we're going to get into kind of the overlays that are really kind of the newer, top of the line, the new trends, whatever you want to call it, right? The first one here is EVPN. And there's a lot of information about EVPN out there these days. A lot of people are leveraging EVPN, and it's a lot for what you need to know from a design perspective. It's the evolution of like VPLS, right? So instead of running VPLS and you have these MAC flooding issues that we talked about already, EVPN actually solves a lot of that. It's actually really efficient for MAC learning, a lot more efficient than VPLS was. So providers don't have those issues if they're running EVPN in their actual MPLS network or the provider network, or even if you're running EVPN in your data centers, right? So as we get into these data center technologies, spine leaf, CLOS architectures, CLOS architectures, you're going to see that we're going to talk about VXLAN and EVPN a lot, because that's what people are using today in both the data center space and as the DCI connectivity between the two. But this option is kind of that evolution of VPLS. It's more efficient, and it's more preferred on a number of things. Mohammed, did you want to add anything else to that?
No, I totally agree with you, Zik. And it's like it initially came to overcome some of the limitations we mentioned for VPLS, like MAC learning, broadcasting, and also VPLS has limitation when it comes to multi-homing and dual sites. And then EVPN is start advance a lot. So now people thinking to not only carry MAC. The beauty about EVPN is using BGP, our old friend. So we are carrying the MAC information in BGP. That's why it's brilliant. So they said, why not also to start carry the layer VPN also in EVPN? So it is improving every now and then. So please keep an eye on EVPN. I believe it's one of the technologies of the future, and you have to learn it if you want to work. It will be in the service provider, in the data center.
Yeah, you're going to have to learn it for sure. So this is just one of those new trends. I would also call out, because we didn't call it out before, that you're going to see a lot of these solutions that we've talked about today, and some of the ones that we're going to continue to talk about here, that people will do multiple solutions together, right? So EVPN has some capabilities and some benefits, and you're going to see people run VXLAN and EVPN, right? Or they're going to run some of the other solutions. So I want you guys to understand that some of these can be individual solutions, design solutions to a problem, but then multiple of these components, these technologies, can actually be combined together to solve bigger problems that you're having.
I agree.
So our next one is VXLAN. right? So on that kind of topic, right, we went from EVPN, now we're talking about VXLAN, right? And at a high level, VXLAN really is that spine leaf architecture, right? We have a data center one, we have our spines, we have our leaves connected to our spines, and this isn't like a full-on deep dive on spine leaf architecture. So this is a very basic diagram of what spine leaf architecture is. High level, right? So spines theoretically don't have anything connected to them except for the leaves. On the leaf side is where all your access devices connect and all your users, right? So that's where you connect all your devices. You'd have different pods of leaves, right? And then for this example, there's a border leaf. So from a data center interconnect perspective, right, we have these border leaves in each data center, and we have redundant connections to whatever transport we're leveraging, right? Again, we could leverage any transport we've talked about today, right? You could use dark fiber if you wanted. You could use DWDM if you wanted. You can use MPLS, whatever flavor of MPLS you want to use, right? You can use any of these concepts as that transport. So what you're doing here, though, is you're doing something else on top of that transport. And theoretically, most of the time, you're going to run some sort of BGP across these border leaves in some fashion. And I am being vendor agnostic, right? So this is all VXLAN information that's getting shared into BGP. And there's going to be some sort of VXLAN controller in each of these data centers. So that's why there's a brain here. If I grab Mohammed's going to laugh at me because I have an issue with this. So we got our brains, right, in each place, right? And that's going to be the whole point is that is our VXLAN kind of controller. He is the one that's maintaining state and understanding what's going on from a VXLAN perspective and who needs what. Different vendors have different ways of doing this. Some of the controllers actually peer up to each other via BGP, and some don't. In some of these architectures, the border leaves peer up with BGP, right, across whatever transport you're running, right? So across the transport. And again, this transport down here, that's your physical connectivity, right? That's what that's supposed to show. And then I have another example on the next slide that I want to show as another option, but is there any questions on this so far? I forgot the shortcut key here, so bear with me. Erase, what is that? If there's no any questions, then I'm going to go ahead and erase the pen here and click the next slide, because there's another option that you could do depending on your provider, where you're running VXLAN in your data centers yourself, right? You're running VXLAN, if that's manual VXLAN without a controller, or if that's with a controller with automation, right? And my term is software-defined data center, not a specific vendor solution. Any software-defined data center has a controller that's going to do your VXLAN configuration for you if you wanted to. But then you're going to have to do some sort of manual mapping here. So your provider could run what's called EVPN, like we talked about. You could run EVPN in your provider space. And then you would have to do this manual mapping of your VNIs to your EVIs, right? So those are two identifiers. VXLAN has a VNI, EVPN has an EVI, and you're just manually mapping them together. And that's going to do an end-to-end segmentation strategy from data center 1 to your provider network all the way to data center 2. I see this a lot in production, so I wanted to call it out. This is very similar to like doing some sort of stitching of VRFs, your VRF light stitching to like MPLS VRFs, or even some of the newer technologies where you're running VXLAN VTEPs to VRFs, right? This is the same concept. We're stitching the segmentation together.
So,
any questions,
yeah,
comments, concerns?
Comment that we cannot cover VXLAN in 2 or 3 minutes. Maybe we can have another session dedicated to VXLAN, but it's a brilliant technology again, covering a lot of limitation when it's come to layer 2, the number of VLAN, the extension of VLAN, because it's like trying to wrap this VLAN into IP header into UDP and then send it. And also with the controller, you are adding SDN and adding application centric. So based on the application, you can decide where to host it in which VXLAN, how to extend it to other side. So a lot of benefits coming with such technology and give you a lot of flexibility. Just if you have a
Yeah, I mean, some of the things you're going to get here, right? You're going to get that layer 2 mobility that we've talked about, right? So you layer 3 if you want it, right? Layer 3 is going to be inherent. Layer 2 is the one that most people really want. So your servers, right? Your applications can maintain their IP address they have in Data Center 1, and they can move over to Data Center 2 on the fly.
Exactly.
Right? And they can keep all their information they have. Now, there's a lot that goes into that. It's not as like, there's no easy button. I want to be very clear. It's not like there's a red easy button that you just hit easy and it just works. You're going to have storage replication depending on how your application works. A lot of it's based on the application, what it can handle, right? But from a routing perspective and a design from routing, you can make this happen. You can make sure that the IPs can live in both places, and that's on network designers, right? That's not on the application designer.
Yeah, exactly. The beauty is like we are using EVPN in this example, like an underlay or a transport to IP VTIP reachability, which is stand for VXLAN tunnel endpoint, and a VXLAN is hiding the IPs of the server. It's actually embedded inside the VXLAN header. That's why it's make it easy to extend the layer 2, make it easy to mobility. If you have, as example, a server today with 10.1.1.1 and data center 2, the green one, and just you want to move to the other side, you can do it without caring about the subnets or how to advertise it or so on. So it's I believe it's a very improved option. Will give you a lot.
Yeah. All right. Any questions? So we're going to go to the next slide if there's not. I have a question then. Anyone using VXLAN today? You can answer that in chat or unmute yourself and oh, Mohammed's using it. All right, so he must be the go-to expert on VXLAN. Everyone ask him questions. Go. Alu, you're using it? Yep, I think you mentioned that, right? That's awesome, man. Great.
So he's the expert now. Ask him, don't ask me.
yeah, right. Don't ask Mohammed, ask him, right? So, no, this is great. I just like to get an idea of using VXLAN. It is evolving, right? And it's constantly evolving. It's fairly new technology. I still think it's fairly new for the last few years, but there's still changes happening to VXLAN. It's getting better. One of the limitations of VXLAN at a high level with these controllers is what happens when you have a link failure, right? If you have a link failure or a provider outage, right, between the two data centers, what happens with your controllers is you have what I would call a split brain situation, right? That's actually why I like this icon that's a brain, because that makes sense. It's a controller. It's the one controlling everything, right? Well, what happens when you have a split brain situation? And that is a limitation today of this design. So if you're going through this, finding a way to mitigate a split brain situation will be key.
Yeah. Even remind me of something, Zig, when we were working on this drawing, I even mentioned that this drawing, as Zig mentioned, just for simplicity, but most of the new recommendation of the design, you should have at least 3 controllers to avoid this problem of split rising. So at least we need to have 3. Yeah.
Yeah, and when we get to the cloud conversation, assuming that you guys follow us along these webinar series, right? You can put a controller in the cloud.
Exactly.
These controllers, most of these controllers, and I'm being general, right? Some solutions may not follow this rule, but most of these controllers are out of line. Like they don't need to be in the data path. Right? They're just control plane elements of the protocols. So you could actually instantiate a controller in like AWS or Azure or whatever cloud provider you're leveraging, and that you always have a way to connect to that controller now. Like it's always out there. Obviously, assuming that the cloud provider doesn't go down, right? So just ideas, right? So I'm gonna move on to the next slide, which happens to be OTV. So this is the only, I believe, Mohammed, keep me honest. This is the only vendor-specific technology that we're going to talk about, and it's OTV. It's a Cisco proprietary technology, and really, it has some benefits, right? So just to call it out, it has some benefits, and that's why we're just talking about it. This is going to build. The slide's going to build a little bit as we talk. So to start out, we have our provider. It's any type of provider. Again, we don't care what the underlay is. It can be L2, L3, MPLS, doesn't matter, right? We're going to go ahead and enable OTV on our edge devices. So as you hear, I did a little text, OTV. That means OTV is enabled now. So just so we're clear, a really quick, easy way. All 4 of our edge devices now have OTV enabled. And what logically happens here is it's like this. So OTV now has this methodology where it's almost like a brain, right? And it's sharing information, and it's making decisions on which devices, which edge devices in this topology are going to be my advanced edge devices, and that terminology is AED, so advanced edge device. And the ones that's identified for the corresponding VLAN that you want to span across data centers, that edge device is the gatekeeper for traffic leaving and entering the location. So VLAN 100 is the one I'm using here as an example, right? So I'm going to get my little pen out here and make sure I can write this. So VLAN 100 here is my example, right? And this edge device and this edge device are the only two edge devices that are going to allow traffic for VLAN 100 to leave and enter both locations. So when it comes up here, if traffic leaves this device, it's going to get checked here and say, yep, you can leave this device. It's going to go up into this OTV kind of magicness, right? And then if traffic comes back down to both of these OTV devices, this OTV device is going to say, hey, I am not the advanced edge device for VLAN 100, so I'm not going to allow that traffic to go out my device. But because this bottom one is, he is the AED, then it's going to allow it. That's a real quick high-level view of how it works. The benefits of OTV is that you're going to be able to logically span layer 2 segments between data centers at scale too. So you can span these to multiple data centers, not just 2. So you can do 3, 4, 5 data centers, right? And so you can span these across multiple data centers if we need to. There is no requirement for the underlay to have layer 2 functionality, right? This is all OTV running on top of your underlay. And that's the benefit you get with OTV. This is not a sales pitch, making it very clear, not a sales pitch, not a sales pitch at all, right? So just telling you the design capabilities of OTV.
100%.
Mohammed, do you have anything else?
Just two more points. It's Cisco proprietary, and as Zig mentioned, we don't have any requirement for the underlay. You have 2 modes. If it support multicast, it will be better. If you have maybe 3 or 4 sites and support multicast, it will make OTV works more, as you said, efficient. If not, we can still use unicast, and it was introduced mainly for layer 2 extension as well.
Yeah, this is a real use case of that layer 2 extension, right? So if you have 2 data centers or 3 data centers, and you want to do some sort of layer 2 extension between them at scale, that's where this fits in, right? But that is 100% where this fits in. All right. Any questions on that? I went to the next slide by mistake, but is there any questions on OTV? No, going once, twice, and 3. So LISP is our last kind of technology that we identified in our list. Again, this was not an all-inclusive list. At a high level, this is what LISP is. But I have to be very clear, LISP is not a DCI solution. That's why I think I had question marks on LISP at the beginning. LISP is specifically a path optimization solution. So what that really means is that when you pair that up with some of the technologies that we talked about today, you can actually leverage LISP to make passing more efficient. So that means return traffic coming back to your data centers can be going to the right data center the most efficient way possible. And then traffic leaving your data center can also go the right way as you want it to. And at a high level, I'm going to briefly discuss what LISP does. So you have EID space, and you'll see that on the slide a couple of times. You have your EID space. I'm going to grab a pen, right? And you'll see that on 3 locations here, right? You don't see it over here in this blue site because this is not a non-LISP site. LISP is not enabled going down from this device, okay? All the other sites have LISP enabled, so they have what's called EID. That's endpoint ID space, right? And those endpoint ID space is going to be really the subnets you're leveraging for your endpoints, your devices, right? Applications, servers, clients, etc., right? So that's the first concept. The second concept here is RLOC space, right? And that's going to be this big kind of gray cloud. RLOC space is going to be all the networking information that you need to identify where these IED spaces live. So this router is going to have an RLOC. This router is going to have an RLOC, right? And this router, it's going to be really just an identifier of how to get to the IED space in question at a high level, right? And then there's a mapping agent, another brain, mapping database, mapping agent, whatever term you want to leverage here, that is literally just mapping the EIDs that we just talked about to the RLOCs, right? So RLOC is resource locator. I don't think I defined it. So we're taking those endpoint IDs, those subnets, and we're saying go to this resource locator, this IP, to get to that subnet, right? Now, how this all works, this mapping agent, I put it here. It doesn't necessarily have to be in line. It is one of those control elements in the out of line, right? So you can have it as a cloud service if you want to do like a virtual router in the cloud. You can have it on-prem somewhere in one of these locations. It really is just a mapping agent. And the rest of these devices, like the XTR here, that is an ingress and egress tunnel router. That's what that stands for. The X is for both performances of ingress and egress. So this router and this router here in Data Center 2, and then this router over here in Site 1, those are all ingress and egress tunnel routers. They all support VXLAN or LISP, and they're all connecting. They're all configured correctly. And they're sharing information to this mapping database so that the mapping database knows how to tell everyone else how to get places. If that makes sense. That mapping database is going to tell all these XTRs how to get to the other locations as well. Now, a site over here, this third site that we didn't really talk about, it's called a PXTR. So it still has that XTR, it's still ingress and egress, but it's called a proxy. So it's proxy ingress, proxy egress tunnel router. And that's because this site is not configured for LISP. So this is going to also configure, this is also going to form some sort of relationship with the mapping agent, right? You have to configure it for LISP. It's going to share information between the two. And that is how this non-LISP site is going to be able to talk to everything else that has LISP and vice versa. So there's a lot, right? What does this mean for you, right? That's really what it comes down to at this point. So what this means is that all of your data center IP addresses, all their subnets are going to get registered in this database. And this database is going to tell everyone that is part of this how to get to your data center, how to what's the most efficient way to get to that space, that network space. And that's how we talk about path optimization, right? We're talking about as efficient as possible path optimization. Any questions? That is really high level overview, right? So a lot more can go into LISP. Mohammed, do you have anything you want to add to this?
Yeah, I was going to say it's another interesting technology has been there for a few years. It was initially for location identity separation, so it was mainly to try to solve the problem of huge BGP. That time it was 700,000 routes, how to reach the best router to get served. As Zig mentioned, how to assure load sharing if you have multiple sites and you are trying to achieve load sharing. So this mapping database or mapping system can help you to send some couple of the traffic to this data center 1, while maybe 60% to data center 2, 40% to data center 1. So initially it was just for IP mobility, and then we are using it to path optimization, load sharing, a lot of use cases. Some people now still, there is like an argument in the market, will VXLAN make LISP obsolete, or LISP, because LISP is still used heavily even within some of the vendor for the SD access for MBBGP, but VXLAN is also trying to achieve some of these use cases. Yeah, again, another exciting topic. It's not, we agree, it's not a data center interconnect, but it's one of the protocols which you can use to enhance your communication with the data center.
Yeah, I'll give you an example real quick after Mohammed just that. If I could go back, actually, it won't let me go back a slide. Let me thought I was muted for a minute there. Let me exit out of this editing here and clear my pen here, and I'll go back a slide if I can. So we talked about OTV a minute ago. Wow, I can't go back a slide. That's horrible. Just user error, guys. Just user error. So OTV, right? We talked about OTV a minute ago, and LISP and OTV actually pair up really well together, right? So you can have some layer 2 spanning of your networks if you need to, but then you can leverage LISP to return traffic to the right data center, right? Because there's no guarantee where that application server is currently living, and its return traffic needs to come back to that same data center, right? If you're routing natively, you're routing for the subnet, right? You're routing outbound to from both data centers. So you need something else to tell the clients to get back to the right data center. All right, cool.
Cool. We have a question, Zegan chat from Ari. Are there any other implementation besides Cisco for Lisp, I believe?
Specifically to what, Lou? Is that Lisp or OTV? What are we talking about first?
Lisp. I was talking about Lisp.
You mean Lisp specifically? Yeah.
Lisp, yeah.
That's a great question. I don't know the answer off the top of my head. I'm not a guy that's going to sugarcoat anything. So, Mohammed, do you have any ideas?
I know it's standard protocol, but to tell you the truth, I saw it in Cisco implementation. I'm not sure if any other vendor implemented, but it's standard. It should be supported by other vendors. But is there any other implementation, maybe using Juniper Nokia? Maybe we can give it a try, but I didn't see it myself.
Yeah, I mean, obviously Cisco uses it a lot in a lot of protocols. It's used in obviously SD access today, or SDA, whatever you want to call it, DNA center, that combination there. I know we used it in FabriPath as well when FabriPath first came out, which is actually the vendor agnostic term is Trill. If you're not familiar with what Trill is, but I only can think of Cisco specific uses of Lisp off the top of my head. So I'll put some thought onto that for you, Lou. And if I think of anything, we'll let you know. I can't think of anything off the top right now, off the top of my head. So, all right. All right. So now we get into our charts. And there's a lot of charts here because for designing, right? Designing, we need to be able to compare things. We need to be able to do these on the fly. So if you are doing network design and you want to become a better designer, great. These charts are going to help you, right? If you're studying for the CCDE, these charts are going to help you, or any other certification that has a design in it, right? I know that CCIE now has all design in it. Other vendor certifications have design in it too. So really these charts help you compare the technologies together, and then you can kind of make the decision that makes the most sense, right? Makes the most value to the business. This first chart is the physical comparison chart. So we're talking those solutions that were really just physical solutions. So dark fiber, DWDM, L2 trunks, L3 point-to-point links. And you'll see there's a whole bunch of values, criteria, I mean, that we put in here, and really comparing where they are across the board, right? Layer 2 extension, we've talked about that a lot today. We want to extend layer 2 traffic. Path optimization, we talked about that just recently. You got all the business use cases that we were talking about, business continuity, workload mobility, disaster recovery, site migration, etc. I will say that there is another call out here for 3+ data centers, right? So everything we talked about today was 2 data centers, but some of the things that would make sense is if you have more than 2 data centers, right? And how do these technologies work with more than 2 data centers? Then there's also scalability. Transport independent, what does that mean? It means is that, does it require anything else to actually function, right? So when we talk about MPLS in a minute, those options for MPLS, they require MPLS, right? So they're not transport independent. Multi-homing, multi-pathing, those are just other options that you can leverage for the solution. Solution complexity, so we did call that out, right? How complex is the solution? And we want you to be able to know that. And then can you do multi-tenancy? Right? Can you actually do some sort of multi-tenancy with the solution, or QoS, efficiency, and then solution cost? But high level, that's what those are. If you have questions on any of those, let us know. Mohammed, did you want to go through everything on the slide, or did you just want to show them?
I just want to you. Maybe we can start the next session by if you have any comment, if you believe, maybe as example, no, actually, DWDM is not expensive. I got it for a very cheap solution. Or if you want, as example, to discuss one of the criteria, which is not clear, but here we just want to highlight, it's very useful to understand each technologies, what does it support. It's still, this is our opinion, Zig and myself. It's open, it's not written in stone. So we can, it's a bit, some of these points specifically are subjective. So as example, when we say DWDM doesn't support multi-tenancy, here we mean if you are building your own DWDM solution, so it's mainly for you as a customer. But if you are talking about a service provider providing DWDM solution, it is at that case multi-tenancy. Yeah, take your time to go through it, and we are happy maybe next session to answer your questions about this comparison.
Yeah, we're going to share these, right, Mohammed? So we're going to share these charts up. This is just the first one. I think there's 4 charts in total. We're going to share them so you guys all have them. Like, this is just stuff to give to the environment, or to the environment. Wow. Like, this is stuff to give to the industry. That's a better word. There we go. Because these charts are going to be extremely useful on making design decisions. But to Mohammed's point here, some of these things are subjective, right, based on experience and your perspective. So while like some of these things we might say the cost is expensive, it may not be expensive in your use case, right? Yes. There might be an option for you that it may not be expensive. That just is what it is. So some of these are subjective, so keep that in mind. Some of them don't have a hard yes or no, and you'll see that as well. So again, this was our dark fiber, DWDM, L2 trunks, and L3 point-to-point links. Our next chart is all of our service provider solutions, right? So MPLS, L3 VPN, MPLS, L2 VPN, VPLS, and EVPN. Same criteria, right? So that column doesn't change. This left green column doesn't change, but then our solutions do change. So we're just trying to show you the comparisons. All right, and then like I said, we'll send these out to you guys afterwards. Yeah. The next one is our overlay technology.
Maybe here,
right? So
just a quick comment, Zig, that it's not, we thought to be a bit fair, it's not maybe ideal to compare maybe MPLS solution with overlay solution. That's why we try to keep it a bit separate, but using the same criteria. So yeah, that's why we divided. This is just what I want to say. We divided like this to make it almost a bit fairness.
Yeah, so we divided that way so it's logical, makes sense, right? And it's fair to the different solutions. I think also it looks better when you put on a slide. It's not this huge chart that you can't see, right? Because if it was one chart and it's this crazy huge chart, right? Now, I will say that some of the overlay technologies and some of the service provider technologies will get compared together at times, right? You can actually run, if I go back a slide, right? So you could actually run some of these service provider technologies on your own, right? But again, this is specifically to DCI. Now, if we decided to not talk about DCI for a minute, and you're trying to find a virtualization technology, you could easily take the service provider solutions and compare them with the overlay technologies as well. It's really just the perspective that we're talking about today, and it happens to be DCI. Okay. Here's the overlay chart real quick. Again, same criteria. We have OTV. We have the GRA IPSec Tunnels, because again, that is an overlay, right? It's our legacy overlay that we've done for years. We do have VXLAN. We have a call out for VXLAN. Did you add that somewhere, Mohammed?
Yeah, actually, maybe I mentioned that VXLAN, you know, that maybe it has some other flavor like NVGRE. It was in the notes, but sorry, it was missed on the slide. Geneva and whatever. So this was the asterisk just to compare. But maybe VXLAN, you consider other flavors.
This is other flavors of VXLAN that's not specifically VXLAN that we could leverage here in place of VXLAN. One of the solutions that we didn't talk about today was Trill. I briefly mentioned FabricPath, which is a form of that. So not something I would definitely recommend for DCI, right? There's some inherent issues with FabricPath and Trill technologies, and specifically around broadcast, unicast, and multicast traffic, which we call BUM traffic. It selects the route of a tree, and it sends all BUM traffic to that route. So if you had multiple data centers, high level, right, real quick, you had data center 1 and data center 2, and let's say your route of that tree was in data center 1, all of your broadcast, unicast, and multicast traffic in data center 2 would have to go all the way back to that tree before coming back to wherever that destination was. It's just an inherent flaw with how Trill and FabricPath work. We didn't call it out, right? I just wanted to highlight it real quick, but we do have it in this chart to compare everything. And then our last chart is specific to special use cases. which has LISP. So that's where our LISP is sitting, because again, LISP is not specifically a DCI solution, but it does not compare. DCI LISP does pair up well with some of the DCI solutions we talked about today. All right, so that's the slides we had, right? We went a little over because we started late. Does anyone have any questions, comments, concerns? Please ask. Free reign, guys. I'm gonna give it a minute. Alu, you unmuted yourself. Go ahead. No, you okay? Muted. So if there's not any questions or comments, I have a question for you.
Yeah.
How was today's webinar? How did you like it?
Yeah. Can you hear me?
Yes, we can hear now.
Yes.
Yeah. So yeah, thank you for this good presentation. I just have a question regarding stitching when we have a VXLAN network connecting to an EVPN. Just to give you a picture, we have a customers connecting to the one using EVPN, and the other side we have a data center. So to connect the customers to the data center, we need the kind of connectivity between the one network and the data center. The one is using EVPN, and on the data center we have EVPN, VXLAN. So how this stitching works, knowing the one is not is from a different vendor. So that's the question.
Yes, I think your question is how the stitching actually works between VXLAN and EVPN. When you're like, so again, let's talk. So you have VXLAN, you're running VXLAN in your provider space, right? Or in your data center space. The words that are in my head aren't coming out correctly. I apologize. So yeah, you have VXLAN in your data center space, and then you have customers of yours that are using EVPN today that are connecting to you. And you're wondering how can you actually do that stitching, right? Is that the question? Okay. So, there is a way to do it. I mean, it depends on the vendor hardware you have, right? So again, if it's Cisco, Juniper, whatever vendor solution we're talking about, right? You're running VXLAN, you're going to have your VTEPs, and you're going to have to do a manual stitching of your VNIs. So when you go in that configuration, however it's done on the syntax, you should see all your VNIs, and you're going to have to manually stitch them to the EVPN EVIs. So in EVPN, there's going to be dedicated EVIs for every kind of segmentation, and you're just going to manually stitch them on either side. Very similar to like, trying to think of an analogy. So very similar to what we do with VXLAN to MPLS today. So VXLAN, we have our VNIs, we have our VTEPs, and we define VRFs within the configuration. And then on our MPLS connections, we have VRFs. So it's almost like back-to-back VRFs, and the VRFs can be different. One side is a VRF, it could be VRF VXLAN 1, and the other side is MPLS VRF, and it could be maybe customer VRF 1. But because they're neighbors shipped across that link, they're going to share information. It'd be very similar to that, but you have to do that manual stitching on that connectivity link. That makes sense.
Okay.
Honestly, the hardest part with doing it, right, at a high level, and we can get the syntax if we need to, if it's a Cisco solution. I'm sure we can find other solutions too out there. The hardest part is scalability, okay? Because how are you going to manage, if you have 100 customers and every single customer needs that stitching, how are you going to manage that stitching, right? Because again, you're stitching that VNI to that EVI every time. It's like a sub-interface. You're doing 100 sub-interfaces across that link. So if you're if you're scaling this, I would say do it small, right? If you got 5 or 10 customers, easy, you can do it, right? But if it starts to get to the 20, 30, 40 customers, this isn't the right solution.
Okay.
Did that answer your question, Alu?
Yeah, it does. It does. Thanks.
Yeah, and I think you get a technical answer, right? Because it's not CLI, right? We can find the syntax. We can find the CLI commands that you could issue. That's not an issue. That's not a problem. I don't know them by heart because I just don't memorize them anymore, but we can find them. Really, it's based on the design situation, right, and how you would do it. High level, that's how I would do it, but there are some limitations. Scalability is a limitation.
Okay, thanks, Dave.
Any other questions? All right, so I'm going to ask for some feedback, guys. So, if there's any questions, how did you like today's webinar? What are your thoughts? Let us know. Real raw thoughts. Like, did you hate it? Did you like it? Did you love it? Whatever. I don't care. I just want feedback.
From my side, this is Aliu. From my side, I really like this webinar, and I had this type of webinar a few years back. It would have really helped me a lot in addressing these technologies. Thank you very much, guys. I'm sure for those who are joining us or watching over YouTube, they're really enjoying this. And I'm looking forward for the next ones. Thanks.
Well, thanks, Lou. Appreciate it, man. Appreciate the feedback. Islam sent us some feedback in chat. Perfect. Summarized different DCI ways. Said perfect. Thank you for the feedback, Islam. I really do appreciate it. I know Mohammed does too. Any last minute comments, questions, concerns? I'll turn it back over to Mohammed if there's not. All right, Mohammed, it's all yours.
Yeah. Thanks again, everyone. As we mentioned, we recorded this session. We'll put it in both our YouTube channels. So you'll find it in Zig YouTube channel and also mine. So whatever, I believe you should watch it in both and subscribe. As well, please keep us take a time. We'll try to share this slides over LinkedIn as a PDF. Take a time to look at the chart, maybe share your feedback, which option you believe it's most suitable for your case, which one you can use in case of DR. So let's maybe enrich this series with some questions, and maybe in the future we can have like a small group and start talking more and more. That's it from my side. Thanks again, Zig, for your time and the effort we spent over the last 2 weeks to prepare this slide. I know we had a lot of sessions to make it this way. And thanks for the audience. Actually, you enriched the session. Thanks for your comment, questions, and even listening to us. And stay tuned for our next session, and have a good day.
Thank you all. Have a good day.
Thank you, guys. Good day.